Today we're going to add and subtract fractions. And actually, if you look at the title of it, it says rational expressions. Remember that a rational expression is any number that can be written as a fraction. And the thing that we're really going to work with is expressions. So I know that the first example has numbers in it. And oftentimes what people do when they see fractions that have numbers in it, you just type it in your calculator. But if you look down farther in the paper, what you're going to see is you're going to see a lot of variables. And even the best of calculators don't add fractions with variables in them. So we need to learn how to do this without. When you add or subtract fractions, just the adding and subtracting, we have to find a common denominator. And the only way that we can change the denominator is by multiplying the overall fraction by 1. So sometimes we call it a fancy form of 1. But as we look at the first one, don't use your calculator to do the example with the 2/3 plus 4/5. Let's do the problem so we can kind of see how it works with numbers, so then we can apply it with the variables. And the other nice part is that it was the very last topic we did in Algebra 2 last year. So if you had Algebra 2 last year, at least you've seen this before. So the first thing that we have to do is we have to find the common denominator between 3 and 5. And the nice part is that 3 and 5 are both prime numbers. So all that we can do with our common denominator is we can multiply 3 by 5 to get the common denominator. And 3 times 5 is 15. That's going to be our common denominator. Well, to figure out what goes in the numerator then, what we have to do is we have to figure out what do we multiply 3 by to get 15? Well, we multiplied 3 by 5 to get 15. There was already a 2 in the numerator, but since we multiplied the bottom of the fraction by 5, we have to multiply the top of the fraction by 5 also. Same thing over here in the next fraction, the 4/5. What did we multiply 5 by to get 15? Well, we multiplied 5 times 3 to get 15. We already have the 4 in the numerator, which is the top of the fraction. But since we multiplied 5 by 3 to get 15, we have to multiply 4 by 3 also. And now that we've got that, we can finish this problem. We can combine it here. 2 times 5 is 10 fifteenths. 4 times 3 is 12 fifteenths. And 10 plus 12 is 22 fifteenths. Maybe it'll show up a little bit better because I see that some of you are still looking a little bit confused. When there's a variable in the denominator, really the only thing that we can do with when we have a variable in the denominator is we can take the x in this case and multiply it by the 8. That's going to give us a common denominator, and on a good day that'll give us the lowest common denominator, or the least common denominator of 8x. And then what we talk about here is what's in the denominator now that wasn't in the denominator before. Well, there's an x in the denominator still. We still have that 7, but now what we have in there is an 8. So we're going to multiply it by an 8. In the fancy form of 1, it shows up a little bit better here in this problem than it did on the last one. 8 divided by 8 is 1. There's the fancy form of 1. Don't cancel it out. Over here with the 8, the 3/8, the 3 is still there, but what's in our denominator now that wasn't in our denominator before? Well, the 8 was there before, and now we have an x. So we're going to have to put in that x. And now we can finish this problem. 7 times 8 is 56. 3 times x is 3x, all divided by 8x. Can we cancel out the x's? And at least one person is nodding no, so that's a good. The 2 yeses, that's not so good. If we cannot factor, we cannot cancel. So we cannot factor 56 minus 3x, so there's nothing that we can cancel. So hopefully at least that's a good introduction. Factoring is still your friend. But what we're going to focus on here is finding the common denominator. And then on the front page, the addition of these fractions, and then we'll move into the subtraction. Well, when we look at our denominator, 4x and 6x, let's focus on the 4 and the 6. What's the least common denominator? And what that means is, what's the smallest number that both 4 and 6 go into evenly? It's not 2. Carter? 12. Now, if you used 24, if you said 4 times 6 is 24, in the end you're going to have to simplify. Doesn't mean that's wrong, just means it's going to be a little bit more work. But hear me one more time. What's the smallest number that both 4 and 6 go into evenly, and we get 12?
So why it's not different now than the problems we just did? Like in the problems we just did, it would have been 8x.
Continue. So once we've decided that 4 and 6, with respect to the numbers, our least common denominator is 12, then we have an x in each denominator already. So we don't have to put something in there, but we do have to take into account that there is a variable in the denominator. And once again, once we determine that, what we're asking ourselves then is, what's in the denominator now that wasn't in there before, so to speak? But we multiplied 4 times 3 to get 12. So we're going to have to multiply our numerator by 3 also. And our numerator is 2x minus 5. So once again, let me actually say it a little bit better. 4x times 3 is 12x. The 4x was already there. We had to multiply by 3 in the bottom of the fraction, so we have to multiply by 3 in the top of the fraction. Over here, 6x times 2 is 12x, so we're going to have to multiply by 2 up here on the top of the fraction as well. But now we have a common denominator, and we have the appropriate numerator. If you're taking chemistry and you're balancing equations, when you change something on the bottom, you got to change something on the top. You've got to keep it in balance. So now, what we can do is we can distribute this 3 here, and we get 6x minus 15. 2 times 4x is 8x. 2 times 2 is 4. But when we add or subtract fractions, once we have common denominator, we add the numerator, we add the top of the fraction, we leave the bottom alone. We leave the denominator alone. And finally, when we combine like terms, we've got 6x plus 8x is 14x. Negative 15 plus 4, negative 11, divided by 12x. Let's try another one. thing is, too, at the beginning I said, factoring is your friend. Just like it was yesterday and the day before. And in order to find our least common denominator, if we factor our denominators first, we're going to be able to find our least common denominator easier. Now, yes, you can multiply 5x minus 15 times x squared minus 9, but in the end, you're going to have to simplify, and probably simplify a lot. So when we look here, we'll make it a little bit simpler on ourselves, at least we'll try to. We have a GCF in this first fraction of 5. And if we factor that out, 5x divided by 5 is x, 15 divided by 5 is 3. Just rewriting the fraction in a little bit better format. In our next fraction, we have x squared minus 9. It's the difference between two squares. Square root of x squared is x. Square root of 9 is 3. Difference between two squares, different signs. Now, when we're trying to find our least common denominator, we look at both denominators and we say, do we have anything that's in both of them? So as you look up here in both of them, we've got an x minus 3 in both of them. So that's going to be part of our common denominator. Well, in the fraction that's farthest to the left, we have a 5 in there. It's in the left-hand fraction, but it's not in the right-hand fraction, so that also needs to become part of our common denominator. And over here in our right-hand fraction, we have an x plus 3 in that denominator that's not in the right-hand denominator, so that also has to become part of our common denominator. And now we have it. So find what's the same, and then look at the other parts. So once we determine what our common denominator is, once we determine that, then ask yourselves, what's in the denominator now that wasn't in there before? So we already have that 4 in there, but what's in there now? The 5 was in there, the x minus 3 was in there, but the x plus 3 wasn't. Don't cancel out the x plus 3's, because x plus 3 divided by x plus 3 is 1. That's the fancy form of 1. Over here to the right, do the same process here. We already had a 5 in our numerator, but as we look at the denominator, the bottom of the fraction, what is there now that wasn't there originally? And both the parentheses were there originally, but the 5 wasn't. So we're going to multiply that by 5. We found the common denominator. We've multiplied by the fancy form of 1, and now we can finish by simplifying this. We're going to distribute here. So we get 4x plus 12. 5 times 5 is 25. And our denominator is 5 times x minus 3 times x plus 3. And maybe you were even able to do this sooner than I, but 12 plus 25, those are like terms, and 12 plus 25 is 37. And 5, x minus 3, and x plus 3. So remember, factoring is your friend. If you're writing down on this paper, I'm not quite sure how to direct you, but I guess I'm going to say start far left, because we're going to take up all the space there. And it might not even be enough space, I'm sorry to say. But I'm going to warn you ahead of time on that. Because we need to factor the denominators before we find the common denominator. So as we look at the first one, the far left fraction, we see 1 times 20 is 20. And our factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Will any of those combine to be 9? 4 and 5. And in fact, it's going to be negative 4 and negative 5. So we get x squared minus 4x minus 5x plus 20. We're splitting the middle. And here's a group. And here's a group. And within our group here, or our first group, we have a greatest common factor of x. And x minus 4. Over here, we've got 5. And x minus 4. Negative 5x divided by negative 5 is x. Positive 20 divided by negative 5 is negative 4. So when we factor this, we end up with x minus 4 times x minus 5. But not only do we have to factor the denominator of our left-hand fraction, we have to factor our denominator of our right-hand fraction. And that is the x squared minus 6x plus 8. I'm just writing it over here so that you can see it. You might be able to fit yours right underneath. But 1 times 8 is 8. And our factors of 8 are 1 and 8 and 2 and 4. Will either of those combine to be 6? Yes. And we end up with x squared minus 2x minus 4x plus 8, splitting the middle. And we have x times x minus 2. We have negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. And then we have x minus 2 times x minus 4. Now that we've factored the denominators of both, I'm going to write the problem again. I think it's a good idea. You decide what's going to work best for you. Right now, you may see that, oh, I'm never going to fit this on my paper. I might need to write on notebook paper. So if you think that's you, now's the time to get out the notebook paper and let's rewrite this problem. And what we have is we have x minus 3. That was from our left-hand fraction. And we're dividing by x minus 4 times x minus 5 now. We're going to add that to what we did over here in red. Our numerator of that fraction was 2. And then we came up with the x minus 2 and the x minus 4 when we factored there in our denominator. So I just wrote it again to help us keep track of everything. And once again, when we're finding a common denominator, what we're looking at is, do we have anything that's the same in both denominators? X minus 4. So x minus 4 is going to be part of our common denominator. Well, in our left-hand fraction, we have an x minus 5, but in the right-hand fraction, we don't have that. So the x minus 5 is going to be part of our common denominator. And we've dealt with the x minus 4 over here in the right-hand fraction, but the right-hand fraction also has an x minus 2, and that has to be part of our common denominator. And now I'm even running out of space here, but I think I could squeeze it in. We're going to be adding these two together. Well, once again, ask yourselves, what's in the denominator now that wasn't in the denominator before? Because we have an x minus 3 that was in the numerator, the top of the fraction. But what's there now that wasn't there before? And the first part is that there's an x minus 2 that wasn't there before. And on our right-hand fraction, our x minus 2 was there, our x minus 4 was there. We already have the 2 in there, but what's there now that wasn't there is the x minus 5. Don't cancel anything out here. X minus 5 divided by x minus 5 is 1. X minus 2 divided by x minus 2 is 1. That's the fancy form of 1. So now we found what we need to help us add these two fractions together. And we are going to have to FOIL over here on the left side, or use distributive property, however your Algebra 1 teacher taught you. And it's going to be x squared minus 2x minus 3x plus 6, first, outer, inner, last if you're using FOIL. We simply need to distribute on our right-hand fraction plus 2x minus 10. And once again, when we add and subtract fractions, we do the work to the numerator. We leave the denominator, the bottom of the fraction, alone. So x minus 4 times x minus 5 times x minus 2. And we're getting closer to finishing here. But we do have some like terms up there in the numerator that we need to combine. Nothing with the x squared, but we have minus 2x minus 3x plus 2x. Those are all alike. And when we simplify that, we end up with minus 3x. We have 6 minus 10, which is negative 4. And then finally, down here in our denominator, we have x minus 4 times x minus 5 times x minus 2. And we take a look at that, and we think, are we done? What do we still have to do? We got to factor the top. It might work out and it might not work out, but let's try it here. So once again, like I said, I was afraid that there wouldn't be enough space. I'm going to try to squeeze it in over here. I'm going to write it. X squared minus 3x minus 4. 1 times 4 is 4. The factors of 4 are 1 and 4 and 2 and 2. And will either one of those factors combine to be 3? Yes. So we've got x squared plus 1x minus 4x minus 4. And we group. And we have x. And then we're left with x plus 1. We had 2 x's, we took out 1. 1x divided by x is 1. We have to write the 1. Minus 4. When we factor out that 4, we better get x plus 1. Negative 4x divided by negative 4 is 1x. Negative 4 divided by negative 4 is positive 1. So we do have an x plus 1, as well as an x minus 4. So when we put that back in, x plus 1 times x minus 4, our denominator still didn't change. But then this goes back to the simplifying expressions. Do we have anything exactly the same on the top and on the bottom? We have the x minus 4. There's an x minus 4 here. There's an x minus 4 there. I cancel those out. And now we can finish the problem. We finished with x plus 1 in the numerator divided by x minus 5 times x minus 2. So I know that took a long time to do the addition. But now that we've done the addition, I think that the subtraction will be a little bit easier. And I do have intentions of finishing these notes. In fact, addition and subtracting fractions mean that we have to find the common denominator. So here now, as we flip over our papers to the back, we still need to find the common denominator, and factoring is still our friend. So once again, the issue may be space on this one. You may want to write on another piece of paper, because we're going to have to factor both. The nice part, at least on problem number 4, is you can write above problem number 4 a little bit to squeeze it in. But what we have to do is we need to factor the x squared plus the 5x plus the 4. But 1 times 4 is 4. And then our factors are 1 and 4, or 2 and 2, which are both very small there. But will either one of those factors combine to be 5? Yes. X squared plus 1x plus 4x plus 4. We factor by grouping. And our GCF is x. We're left with x plus 1. Over here, our GCF in the second group is 4. And we're left with x plus 1. So we have x plus 1 times x plus 4. And that's the factoring of our left-hand denominator fraction. But we also have to factor our right-hand denominator, which is the x squared plus the 12x plus the 32. And 1 times 32 is 32. And the factors of 32 are 1 times 32, 2 times 16, 4 times 8. And as we see, the 4 and 8 will combine to be 12. And we get x squared plus 4x plus 8x plus 32. And here's a group, and here's a group. We get x times x plus 4. Greatest common factor is 8, and we're left with x plus 4. And then we have x plus 4, and our x plus 8. And once we get that written, I'm going to rewrite the problem. I write a lot on the subtraction problems. But once again, we're going to, if you do choose to rewrite, then over here with our left-hand fraction, we have x minus 2 in the numerator. And then our factored form of the denominator is x plus 1 and x plus 4. This time, we're subtracting. So I want to emphasize that by putting that in a different color. Our denominator, which I can see up here in black, is the x plus 4 times x plus 8. And as I scroll back up here just to look at the numerator, our numerator is 8. So once we get everything factored, just like addition, we need to look and see, do we have anything that's the same in both of the denominators? And we do. We've got an x plus 4. So x plus 4 is going to be part of our common denominator, because it's in both. As we look at the left-hand fraction, what we see is that there's an x plus 1 in that denominator that's not over here in the right fraction. So we're going to put the x plus 1 in. And in the right-hand fraction, we have an x plus 8 that's not over here in the left-hand fraction. So we need the x plus 8. And now we have the common denominator. So let's ask ourselves, what did we put into the denominator that wasn't there before? Well, we have an x plus 1. We have an x plus 4. The x minus 2 was already there. That must mean that we put into that denominator an x plus 8. Remember, x plus 8 divided by x plus 8, that is the fancy form of 1. Don't cancel it out. Over here, we have an 8 in the numerator. That's not going to go away. We had x plus 4. That's still there. We have the x plus 8. But what we put into our denominator over here on the right side is we put into it an x plus 1. And I don't think that it's as big a deal, but I am going to write one extra step on this problem that I don't typically write in the addition problems. Because we need to be very, very careful with this blue sign here. But this is going to be x minus 2 times x plus 8, which we're going to have to FOIL here in a minute, minus 8 times x plus 1, all divided by x plus 4 times x plus 1 times x plus 8. So I wrote that step. And again, for some of you, you're going to have to write it. For some of you, you're not going to have to write that step. But we need to be careful because this negative gets distributed over the entire right-hand fraction. But we get x squared plus 8x minus 2x minus 16 when we FOIL. And then it's going to be minus 8x minus 8, distributing the whole part there, all over a common denominator of x plus 4 times x plus 1 times x plus 8. And then we can combine like terms. Well, we've got x squared. 8x minus 2x minus 8x is negative 2x. Negative 16 and negative 8 is negative 24. Divided by x plus 4 times x plus 1 times x plus 8. So now, here, we need to split the middle one more time. I'm not going to show the work on it, so we can get it finished here. But x squared minus 2x minus 24 factors. And again, I'm not showing the work on that. I'm just going straight to the factoring here. Factors of 24 that combine to be 2 are 4 and 6. And it has to be a negative. It's really split the middle. I didn't show the work on that. I don't want to run out of time on this problem. So we factored x squared minus 2x minus 24. In our denominator, we have x plus 4, and x plus 1, and x plus 8. And as we look at that, to finish here on this problem, do we have anything exactly the same on the top and on the bottom? The x plus 4s. Once again, we were able to factor, and that's why we can cancel. And now, what we have is we have x minus 6 divided by x plus 1 times x plus 8.